Hello friends, welcome to the course on digital electronics. Let us see some interesting questions. I will have tried my level best to cover in this 1 hour session as much as possible so that it will be beneficial for the students. So now let us see. So let's take up the first question. If you see, please go through the question please. Now a multiplexer is given, a T flip-flop is given. The values of I0, I1, I2, I3 respectively, the values of I0, I1, I2, I3 respectively, such that the circuit works as JK flip-flop. That means what is he trying to do in this question? He gave a T flip-flop and a multiplexer. क्या किया question में? He gave a T flip-flop and a multiplexer. This combination should work like a JK flip-flop. If you remember this question basically comes under the category of flip-flop conversion. आपने पढ़ा होगा, you might have read it, flip-flop conversions. So this question is a hybrid two, I have added two, it's a basically hybrid combination of two questions, a multiplexer question and a flip-flop conversion question. So now let's understand what is the flip-flop conversion. क्या है flip-flop conversion बताइए. Suppose for example you are having a T flip-flop. Okay. Suppose you are having a T flip-flop. Okay. You want to construct a JK flip-flop. आपके पास T flip-flop है. आप JK flip-flop construct करना चाहते हैं. You want to construct a JK flip-flop. How will you do it? Normally what do? We connect some combinational circuit. Normally we connect a combinational circuit. Okay. And this is the normal construction of the JK flip-flop. Okay. आपके पास T flip-flop है. You have to construct a JK flip-flop. What will we do? We take some extra combinational circuit and then create a total JK flip-flop. Understand? Total JK flip-flop. इस क्वेश्चन में क्या किया? In normally हम क्या करते हैं? What do we do normally? We design using the gates. K map, AND gate, OR gate, XOR gate से design करते हैं. We normally design. But in this question he gave a multiplexer. Okay, so let's quickly see how to solve this question. It's very simple. It's a question based on flip-flop conversions and the multiplexer. Okay, so let's solve this question. Now, so first of all, what is the flip-flop you want? You want a JK flip-flop. Okay, first write the state table for the JK flip-flop. If you remember the flip-flop the conversions, आपको जो चाहिए वो पहले लिखना चाहिए. आपको JK flip-flop चाहिए. In the given question is asking for a JK flip-flop. Now we have to first write the state table of JK flip-flop. We have to write the state table of JK flip-flop. Let's write it. Okay, 001. This is 010, 011, 100, 101, 110, 111. We all of us know the JK flip-flop working. क्या है JK flip-flop working बताइए? J0 K0. See, J0 K0 कौन सा condition है? J0 K0. J0 K0 is hold condition. Hold का मतलब क्या है? Whatever is the present state, same will be next state. Okay? Q means present state. Q plus means next state. जो भी present होगा वही next होगा. तो you will have the same state. Okay? Next let's come to 01. 01 कौन सा condition है बताइए? 01. 01 is a reset condition. 01 कौन सा condition है? Reset condition. So flip flop will be reset. Okay? What is 10 condition? See, JK 10 condition. Okay? Whenever JK is 10, the flip flop will be set. Okay? What is 11 condition? Tell me 11 condition. Toggle condition. Toggle means what? बताइए. Present state 0 है तो 1 होगा. Present 1 है तो 0 होगा. This is the toggle condition. So this table what we have written, यहाँ पे हमने जो table लिखा, the table is called the state table. Please understood state table. ठीक है, हमें ये चाहिए. This is what I want. See in the given question, what is that I want? I want the JK flip-flop. I want a JK flip-flop. Okay. Now, but I have the T flip-flop. So what I'm supposed to do? Using the T flip-flop, I need to find out the JK flip-flop. I need to construct a JK flip-flop. मेरे पास T flip-flop है, मुझे JK बनाना है. So how will I do it? So I have to find the basically हमने क्या किया? We are connecting something for the T. T पे कुछ connect करके इसको JK बना रहे हैं. Let's repeat again. I want a JK. I don't have JK. I am having T toggle flip-flop. So something you connect here, something you connect here, something you connect here, so that overall circuit will behave like a T. Simple. Okay. Now what should be connected at T? What should be connected at T? Let's find the logic. How will you find? So you have to find the T value. Simple. You have to find the T value, please. Understood? T value you have to find. Okay. So you want a JK. You are having a toggle flip-flop. So something you connect here so that this entire circuit will behave like a JK flip-flop is the question. So let's find the T value. How will you find the T value, please? Okay. Let's find the T value. So in order to find the T value, how will you find? You have present state, next state. Use the excitation table. If you remember the excitation table of a T flip-flop, Q plus JK, sorry, this is 0001, 1011. What is the excitation table? If you remember 0, 1, 1, 0. This is the excitation table because when both are same state, present next to same, it will be 0. Present next to same, it will be 0. Remaining case toggle condition. This is the excitation table of T flip-flop. Now let's do it, please. Present 0 next to 0. Hold condition. present one, next one, hold condition, 0 0 hold condition, 1 0 toggle condition, hold condition, toggle. Okay, so this is my story. So t value I got. So now if you see, the t is a function of j comma k comma q. Okay, t is a function of j comma k comma q. And if I write the minterms, what are the minterms? 3 4 6 7. So the minterms are sigma m of 3 comma 4 comma 6 comma 7. Okay, so now this is my t function. My t is a function of j comma k comma q. Okay, which is the minterms are 3 4 6 7. So now in the given question, if you see, what is he asking? He is asking the inputs of multiplexer. Okay, now so we found the t value. I found the t value. Now we have to solve this part of the circuit. Now we have to solve this part of the circuit. How will you do it? It's very simple. You have a function. We have to solve this. Okay, let's do it, please. Okay, let's do it, please. Let's take one more slide here. Now what is happening here? If you just observe here, you are having I0, I1, I2 and I3. Okay, so so here select lines are j and k. Okay, S1 S0 are jk. So he is asking for the t, which is a function of j comma k comma q, understand? J comma k comma q. So now in this given question, he is asking the I0, I1, I2 values. How will you solve? So you know that simple. How do you solve this? It's a function of 3 variable, 2 select lines. It's a 4:1 mux. Okay, so here it has to be function of q. It has to be function of q. Okay, we already know how to solve a multiplexer question. Now solve it. I0, I1, I2, I3. Okay, so let's write simply jkq. You might have already studied this method. I have taught in the class jkq. Now when will I0 get selected? jk00. Okay, I1 will selected jk01. Okay, I2 will get selected jk1011. Okay, missing variable q, 0 or 1, 0 or 1, 0 or 1, 0 or 1. Over. Now this is q bar, this is q. All of us know this technique. So that's why I'm slightly speeding up. Now what are the minterms we got? Tell me, what are the minterms? We got 3 4 6 7. We got 3 comma 4 comma 6 comma 7. Now make a selection. So we select the 3. Okay, next 4, next 6, next 7. Now tell me, what is the answer here? Nothing is selected. 0. Bottom selected. What will you say? Bottom selected, q. Top selected, q bar. Both are selected. What will you say? Q bar plus q, which is 1. So the values are 0, q, q bar 1. Okay, this question is basically a combination of 2 questions. Okay, so flip-flop conversions as well as this. So if you just see, the option B is the correct answer, 0, q, q bar 1. Okay, so it's not at all difficult. What I have done is, normally multiplexer is not given. Okay, we find the logic using K-map. मैंने क्या कर दिया यहाँ पे क्या किया? I have just added a multiplexer so that 2 questions are covered at once. Okay, this question can be expected, okay, for 2 marks or 1 mark also. If you are easy get for 1 mark electrical, it can be asked for 2 marks, please, because 2 questions are there in 1 question. It can be expected for 2 marks, please. Okay, friends, I hope you have understood. This is question based on the flip-flop conversions and multiplexer. So इस question में हमने 2 चीज cover किया. ठीक है? So now let's go to next interesting question. You please go through this question. This question is a very simple question if you understand the logic. ये question एक बार पढ़िए. You please see the question. What is he telling? He is giving a 4-bit PIPO. Okay, what is PIPO? Parallel input, parallel output. Parallel input, parallel output. Okay. Now he is telling and he is giving this PIPO output to a full adder circuit for a 4-bit adder. Okay. He is telling the circuit is performing A plus B. This circuit is performing A plus B operation. That means addition is doing. Simple. Now, so what is he doing? The output is fed back to this PIPO, and this output is fed back to this PIPO. Now he is asking initial value is 1010. Okay. After how many clock pulses it will be 1010 again. Please question देखिए. ये question बहुत ही simple है. I'll tell you the logic. It's so simple. Only to confuse people I gave the question like this. But in some question can also come like this. In examination questions may not be tough. They'll be tricky. ठीक है. एक बार question देके आपको समझ में आ जाएगा. एक PIPO दिया है. It's a simple parallel input, parallel output. So when I say PIPO, it means that these are the D value. You can say D3, D2, D1, D0, and these are the Q values: Q3, Q2, Q1, Q0. It's a parallel input, parallel output register. These are the D inputs. These are the Q outputs. Okay. So of course, you know, Q plus equal to D for a clock pulse. Now what is happening? Just let's have a common sense. So what is happening here? The B value is fixed to VCC. Just observe here. B value is fixed to VCC. So what is happening here? And this C0 is fixed to 0. You can see the C0 is connected to ground. The C0 is connected to ground. Okay. This is fixed to VCC. VCC means what? VCC means 1. Okay. So that means what is happening? The A values are getting added with 1. the A values are getting added with 1 1 1 1, okay, and the initial carry is 0. So let's understand what is going to happen. If you see here, this is simple question. A PPO is given, full address is given. He is asking initially 1010. After how many clock cycles it will be 1010 again. कितने clock cycles के बाद ये दोबारा 1010 होगा. After how many clock cycles it will become 1010 again. So I just, to complicate the things, I gave it like this. But if you laugh if I tell the complete solution. Okay, you see how it PPO means, you all of you know, parallel circuits, parallel D flip flops. Okay, this is the D value, this is the Q value. Chalo. Now what is happening in the adder? You are adding that, you are taking the A value. This A value is getting added with B value, where B is fixed to 1 1 1 1. Okay. So now I'll just tell you the funny part, please. You just see here. Okay. What is happening? You are having, okay, A3, A2, A1, A0. If you don't think properly, अगर आप सही से नहीं सोचेंगे इसका सही direction में, you will end up losing time. Okay. So now what are you trying to add? You are trying to add 1 1 1 1, which is my B value. Okay, initial carry 0, initial carry 0, this is my B value. So I'm performing the addition between these two. Okay, so now can I write it like this? Just think, I will write this as A. Okay, this is basically if you see here, okay, it's nothing but 2's complement of 0 0 0 1. Okay, 2's अगर 0 0 0 1 का 2's complement लेते हैं, just think in the other way, अगर 0 0 0 1 का 2's complement लेते हैं तो यही आएगा. Understood? Only, sorry, only 4 bits are there. Sorry, 4 bits. Okay, 1 1 1 1 अगर इसका 2's complement लेते हैं तो ये आएगा. ठीक है. So now what is happening? What does it mean? This basically means, इसका मतलब क्या है? It means that A plus 2's complement of okay 0 0 0 1. Okay, इसका मतलब क्या है? 2's complement का मतलब क्या है? -1 only. This means A -1. तो ये सर्किट क्या कर रहा है? A -1 कर रहा है. Okay, the adder circuit यहाँ पे जो है, if you just observe here, ये तो PPO है, is only for data storage. ये register है. This is only a register where data gets stored. Now what is this, please? This is performing A -1. Okay, ये circuit क्या कर रहा है? When you perform the addition with 1 1 1 1, this is the 2's complement of 1. ये है 2's complement of 1. So this A is added with 2's complement of 1. So this means A -1. So the output is basically A -1. Okay, and what is my A? A is nothing but Q only. Okay, so what is happening? Decrement is taking place. What is happening? Decrement is taking place. So initially 1 0 1 0 is there. This is basically decrementing. A -1 is performing. Okay, and the new value will get stored. For every clock cycle, decrement will happen, new clock cycle will happen. So this is basically a down counter. ये पूरा circuit क्या है? It's a down counter circuit. Understood? It's down counter circuit. पूरा circuit को हम बोल सकते हैं. You can call the complete circuit as a 4-bit down counter. That's it. ये simple एक 4-bit down counter है. Okay. सिंपल कैसे? दिस ओनली डाटा स्टोरेज और यहाँ पे डिक्रीमेंट हो रहा है. दैट मीन्स क्या हो रहा है? लेट्स अज्यूम दैट, एक बार देखते हैं. सो लेट्स सी इट वंस प्लीज. लेट्स सी. ओके, सपोज यहाँ पे 1 0 1 0 आया. ओके, आपने क्या किया? 1 0 1 0 इनिशियली 1 0 1 0 है, आपने A -1 कर दिया. जब A -1 करेंगे तो क्या होगा? यहाँ पे 1 0 0 1 आएगा. ओके, सो क्या होगा? डिक्रीमेंट हो गया है. ये डिक्रीमेंटेड वैल्यू यहाँ पे जाएगा. अंडरस्टूड? यहाँ पे जाएगा, डिक्रीमेंटेड वैल्यू यहाँ पे जाएगा. Clear? So the decremented value is going to go here. So now पहले 1 0 1 0 था, अभी 1 0 0 1 आ जाएगा. Simple. So what is happening here? Initially 10 is there, 10 is getting decremented, going back, and 9 is coming. Again 9 आएगा, gets decremented, again goes back. Again gets decremented, goes back. So this is basically a simple 4-bit down counter. Now tell me, my friends, what is the mod number of a 4-bit down counter? 16. So the answer for this question is simply single stop 16. Okay, so the answer for this question is simple 16 because it's a 4-bit down counter. Okay, this is only data storage. यहाँ पे मैंने क्या किया? Decrement करवा रहा हूँ. I'm making this particular part to decrement it. So decrementing is taking place here. This is the data storage. So these two combination is going to just behave like a down counter. Okay, so down counter, what happens? You decrement. After 10, 9 will come. After 9, 8 will come. 7 6 5 4 3 2 1 0, and again cycle repeats. So it's a simple 4-bit down counter circuit. But students, what they do, they get confused. Confused हो जाते हैं. ठीक है, क्वेश्चन देख के क्या पूछा है and all these things. It's pretty easy, pretty simple, please. Understood? बिल्कुल tough नहीं है. Okay, it's not all difficult. The circuit, entire circuit is equal to 4-bit down counter. अगर किसी को दिक्कत, you can check it, please. यहीं पे लिख देता हूँ. देखिए, initially 10 है. Okay, decrement हुआ 9, clock pulse पे store हो जाएगा. So 9 क्या होगा बताइए? अगेन उसके बाद 8 होगा, 7 होगा, 6 होगा, 5 होगा, 4 होगा, 3, next 2, 1 के बाद 0 होगा. ओके, 0 के बाद क्या होगा? अगेन इट विल गो टू 15 ओनली. ओके आप चेक कर सकते हैं, अगर किसी को डाउट है चेक कीजिएगा. यू हैव 0 0 0, सपोज यू हैव 0 0 0 0, एज्यूम दैट यू 0 हो गया यहाँ पे, assume 0 ho gaya, you are having 0 0 0 0, when you add 1 1 1 1, what happens? 15 will happen. Okay, so it will go to 15, next it will get keep on decrementing like this, 14, okay, 13, next this is 12, this is 11, this is wapas 10. You can just check count, it's a 16 is the answer, it's a mod simple, it's a 4-bit down counter circuit, understood? 4-bit down counter circuit. The question is pretty simple, not at all difficult. If some tricky question comes like this, please observe 1 second, okay, not 1 second but 10 second you just see, for 10 seconds you see, you will get the answer for this question, please. Okay, so now now let's take up this simple circuit. Okay, now let's take up a CMOS circuit. Okay, this is very simple. If you, but when you see this question, people will get scared. Okay, kya kya diya, what is happening here, we are not able to understand and other things. But if you see the question for 2 seconds, you will understand this question is very simple. So please, you just see this question, understood? Question looks like a CMOS, we have a lot of things are there, but the question is a simple question based on transmission gates. Okay, these questions can be expected for 1 marker. Okay, these model questions can be expected for 1 markers for both ECL and electrical. EC of course compulsory hai. Electrical may okay, he may ask it, he may not ask, but EC damn sure these model questions will come. So now if you observe here, let's see what is this circuit. This circuit is based on a simple concept of transmission line. Okay, sorry, transmission gates पे ऊपर है. We have done many questions of this model in the class. कई questions we have solved these model questions in the class, but I have redrawn it. I have just redrawn the circuit so that people will get confused. Okay, I've just redrawn it so that people will get confused. So let's understand this interesting question. Okay, suppose for example, if you remember this transmission gate, let's see the working of transmission gate. Okay, this is a simple wonderful switch. Okay, a transmission gate. You are having an NMOS transistor and a PMOS transistor. Okay, let's say this is A, this is Y, this is control C. Okay, here, right, let's see. So always we run it through an inverter. Okay, run it through inverter. Let's see the working of this circuit. This is called a transmission gate. These circuits are used there. Okay, these circuits are used there. Let's see how it works. First let's understand the working principle of a transmission gate. It's an ideal switch. Practically many applications use transmission gates. Okay, because the circuits transmission gates an ideal switch. Okay, very it has got in the class I might have covered, it has strong pull up, strong pull down. When you compare with the past transistor logic. Okay, so I'm slightly going please check your notes. For electrical friends this point is not required, but EC friends, yes, please look here. I've already covered about strong pull up, strong pull down. This circuit has a strong pull up, strong pull down. Past transistor logic mein kya dikkat hai? What happens in past transistor logic? If you just observe here, the pull down is good but pull up is bad. In the past NMOS past transistor logic, NMOS past transistor logic mein, the pull down is very good but the pull up is bad. That's the nature of the NMOS circuits. But this circuit has a good pull up, strong pull down. Now let's see the working of this circuit. Isko dekhte hain, uske baad let's go to the question. Suppose for example you give C equal to 1. Both are switches. Okay, whenever I give C equal to 1, what happens? So same time C bar will be 0. C1 है तो C bar 0 होगा ना. 1 के लिए NMOS on होगा, 0 के लिए PMOS on होगा. So what is going to happen is both the switches are on, please understood, both the switches are on. From digital perspective you see both switches are on and we can say my Y is equal to A. Okay, both switches are on and Y equal to A. So input is equal to output. Suppose for example if I give C equal to 0, मान लीजिए C 0 देता हूँ. If I give 0 here, what happens? अगर यहाँ पे 0 देते हैं तो what happens here? It becomes 1 here. So NMOS is off, PMOS is also off. Understood? Same time both are off. So NMOS is also off, PMOS is also off. So what happens please? So if you just observe here, both switches are off. Okay. So if you see when both switches are off, NMOS is off, PMOS is off whenever C is 0 के लिए. So what happens please? If you just observe here, okay, the output is not connected to input. It is called the high impedance or open circuit condition, where the output is not equal to input. It's an open circuit condition. Okay, this is the simple working of a transmission gate. Okay, now let's come back to the question. Okay, let's come back to our question. In this given question, if you just observe here, in a transmission gate, एक और चीज, one more point. Transmission gate NMOS is parallel to PMOS. Transmission gate में क्या क्या है? NMOS is parallel to PMOS. Okay, so now let's see here. This part of the circuit, if you just observe here, okay, It is NMOS parallel to PMOS. Okay, and NMOS parallel to PMOS. I just tilted it like this. Okay, here also NMOS is parallel to PMOS. NMOS is parallel to PMOS. Okay, NMOS is parallel to PMOS. Okay, there are two transmission gates. This is one transmission gate. This is one transmission gate. Okay, there are two transmission gates here. So now, so interesting point is what is happening. There is one switch you can say, and what is getting connected here? B is coming here. Okay, the same B is coming here. Okay, now this is B bar. This is B bar. Please, this is B bar. The same B bar is coming here, and the same B bar is coming here. So if you just observe here, this is a simple transmission switch. So I can write this entire question like this. So simple transmission switch. This is one transmission switch. Okay, one transmission switch. We can actually directly do it. 1 second mein ho jayega, but just I wanted to complete it. Okay. So now this is one transmission switch where A is connected here. A is connected here. This is output Y. And what is connected to the NMOS? बताइए. NMOS पे क्या है? B है. NMOS पे B है. And this fellow is B bar. Okay. Similarly, if you just remember, okay, this is one more transmission gate. This is one more transmission gate. Okay. So now, okay, so now this one more transmission gate, and what is connected here? Is bar बताइए. A bar is connected here. A bar is connected here, and here NMOS has B bar. NMOS has B bar. Okay, and the PMOS has B, and the PMOS of this transmission gate has B. PMOS has B. Okay. And what is happening? This output of common output, both are having common output. Both are having common output. This model question we covered in the class. Okay, this model question हमने class में कई बार cover किया. Directly by seeing only we can tell the answer. 30 seconds, 32nd minute, 2 seconds में answer आ जाएगा. So answer क्या है बताइए? So it is A into B. Okay, just A into B. NMOS का देखिए A into B plus this is A bar B bar. Just you should see the NMOS. Okay. So this is B into A plus this is B bar into A bar plus this is A bar B bar. What is A into B plus A bar B bar बताइए? It's a simple XNOR gate and a XNOR gate. So question can also be twisted like this. It's not difficult but very good for one marker. In examination when you see like this, what happens is you will get shocked. Okay, we are used to, in class we have taught like this. Class में ऐसे पढ़ाया. But suddenly in examination you will see questions like this. So he will twist it. It's not all difficult. Okay. Second possibility is, second way of solving is give 0 0 0 1 1 0 1 1. Give 0 0 0 1 1 0 1 1 and solve it. But in my opinion, just think a little bit, answer आ जाएगा. You can easily understand. NMOS parallel to PMOS transmission switch. NMOS parallel to PMOS transmission switch. Okay. And transmission switch में one more condition is, if NMOS is having B, okay, PMOS should have B bar. अगर B है तो B bar होना चाहिए, B bar है तो B होना चाहिए. That's the basic story of the transmission gate. So this question is also very simple question where we are having this particular CMOS circuit. Okay, CMOS circuit. So this question can be expected for 1 mark. If you are easy, my friends, definite question from CMOS, 100%. Okay, there's no doubt about it. Right. Let's go to the next question. Okay. Now let's come to some interesting questions. This is mostly important for EC. Okay. You please go through the question for a moment. एक बार question पढ़िए. क्या दे रहा है? For the asynchronous circuit shown above, ये एक asynchronous बोल रहा है. Okay. He's telling that it's an asynchronous circuit. The maximum clock frequency is asking. He's asking the maximum clock frequency. If the clock duty cycle varies from 40% to 60%. Okay. 3 important points here. 3 important points. What are the 3 important points? 1. It's an asynchronous circuit. Okay. Why asynchronous? Same clock is connected. बता दूंगा. I'll now tell why this is asynchronous. Second thing, he's asking clock frequency. Third point, okay, he's telling the duty cycle of the clock. Now question is, what is duty cycle? Okay. Suppose let's understand what is duty cycle of the clock. Okay. Let's understand what is duty cycle of the clock. Okay. What is the clock duty cycle? Duty cycle is defined as on time divided by, okay, on time plus off time. Okay, that is the basic meaning of duty cycle. This all of us know. In analog electronics, in multivibrators design and other things, we might have studied the duty cycle business. So duty cycle का मतलब क्या है? Suppose for example, if I have something like this, okay, okay, assume that this is 0.4 t, this is 0.4 t, and this is 0.6 t. Okay, 0.6 t. This waveform, assume that this is called on time. Okay. This part is called the on time, please. Okay, this part is called the on time. This part is the on time. Okay, this part is the on time, and this part is the off time. All of us know. Okay, this is called the 40% duty cycle. Okay, so this is called the 40% duty cycle. Okay, similarly, if I just draw a waveform like this, sorry, 1 second please. Okay, if I just draw a waveform like this, so we can say this is 0.6, on time is 0.6 t, this is 0.4 t. Okay, so here this waveform has a 60% duty cycle, this waveform has a 60% duty cycle. So this is the story. So this duty cycle means on time divided by total time. So that means a clock has a variable duty cycle. Just imagine clock has a variable duty cycle. Okay, let's go back to the question. Now read the question. So he's telling that the D flip-flops have 0 delay. D flip-flops have 0 delay. So the TPD of the flip-flop, okay, is 0 nanoseconds. No problem. The TPD of this flip-flop is also 0 nanoseconds. The only delay that is present, is the combinational delay. Okay, the only delay in this entire circuit is basically for the combinational circuit. Okay, no other delay. Over. What is the second part of the first part of the question, by the way? He is telling the circuit is asynchronous. Circuit is asynchronous. Why is it asynchronous? क्यों? क्योंकि आप check कीजिए what is happening here. Same clock is connected, but this circuit is positive edge triggered. ये positive edge पे काम करेगा. This part of the flip-flop works on the positive edge. Same clock is connected, but this part of the circuit works on the positive edge, and this part of the circuit works on the negative edge triggered. So this flip-flop is positive edge triggered, ये negative edge triggered. ठीक है? Suppose for example, if I have a clock pulse, आपके पास एक clock pulse है. Okay? If I give a clock pulse, यहाँ पे clock pulse देता हूँ. I give a clock pulse. Okay? तो पहला circuit कब काम करेगा भाई? When does the first circuit work? Tell me. The first circuit. Okay, the first fellow works on the positive edge triggered. The first fellow works on the positive edge. ठीक है? The second fellow works on the negative edge. यानी the two flip-flops are working at the different time instants. The first flip-flop is working on the positive edge. The second flip-flop is working on the negative edge. Okay, so both are working at different times. So it's a 100% asynchronous circuit. ठीक है? Next. Now I'll ask you one question. This has 0 delay. Ideally, this also has 0 delay, no problem. Okay, so now what is going to happen if you just observe here? Okay, first flip, suppose for example for this pulse, first flip flop is working. Okay, once first flip flop works, what happens? Within 0 time, this output will come. Okay, but what don't you think once this output comes, this circuit will start working? Okay, this circuit produces okay, output after 10 nanoseconds. Okay, this is coming at 0 nanoseconds. I give the clock pulse by. When I give the clock pulse, what is going to happen? पहले ये काम करेगा. First this is going to work. Once this comes, this is coming at 0, but this is going to come at 10. Okay, don't you think I can apply this should work only after 10 nanoseconds? Okay, yeah, this fellow, okay, should work only after this because this should become stable, right? We have something called setup time, hold time constraints. We'll see in the next questions. वो बहुत important है for easy. Okay, so this fellow can work. ये कब काम कर सकता है? This fellow can work only. Okay, this fellow can work only when this is stable. ये पूरा यानी आप you created disturbance. This is working first. This has to work. Then only this has to work because it's asynchronous in nature. ठीक है? That means what should happen between the working of the first flip flop and the second flip flop? Don't you think the delay should be for 10 nanoseconds? Okay, the delay between these two fellows should be equal to 10 nanoseconds. That means first flip flop पहले ये trigger हो रहा है, उसके बाद ये trigger हो रहा है, दोनों के बीच में the delay should be पक्का 10 nanoseconds. Okay, here I gave 0 nanoseconds, here I gave 0. Otherwise what should happen? Ideally this also should get added. Ideally what should happen? This also should get added here. Okay, but anyways we have 0 is given in the question, so no problem. So first see this is asynchronous. Why is it asynchronous? First flip flop is working here, second flip flop is working here. In between these two, see once this gives the output ना, जब ये output देगा, उसके बाद ये disturbance is created here, so this will work. जब ये खत्म होगा उसके बाद ही ये शुरू कर सकते हैं. Once this is complete, then only we can start this. पक्का, this means what? The distance between these two should be पक्का 10 nanosecond. Okay. Now let's go back to our case. Okay. So our duty cycle can vary from 40 to 60%. Duty cycle can vary from 40 to 60%. Whatever may be the duty cycle, 100% एक चीज पक्का. Okay, one flip flop is working here, one flip flop is working here. Okay, one flip flop is working here, one flip flop is working here. Okay, one flip flop is working here, one flip flop is working here. Whatever may be the duty cycle of the clock, whatever may be the duty cycle of the clock. One flip-flop works here, one flip-flop works here, and pakka the distance between these two should be 10 nanoseconds. Okay, the distance between these two should be minimum 10 nanoseconds, minimum 10 nanoseconds. Okay, because in this either the clock is 40% or 60% or 50% for that matter, or 45%, any duty cycle, pakka the distance between the positive edge and the negative edge should be 10. Okay, now what is the minimum most case in 40 to 60%? Okay, minimum most case क्या है, minimum case क्या है, what's the minimum case? Because हर केस के लिए satisfy करना चाहिए तो minimum case लेना चाहिए. ओके, यानी इस केस में भी काम करना चाहिए, अगर इसमें काम करेगा तो इसमें भी काम करेगा ही. एक और बार, my first flip flop is working here, second will work here, first is working here, second is working here. ओके, ठीक है, राइट. My clock can change from here to here. मेरा clock जो है यहाँ से यहाँ change कर सकता है, यानी my circuit should work here also for this clock also, and my circuit should work for this clock also. That means my circuit should work, इसको भी satisfy करना चाहिए, इसको भी satisfy करना चाहिए. अगर इसमें satisfy करेगा 10 nanoseconds, if I satisfy 10 nanoseconds here, ये तो automatically this will get satisfied because this is more than 10, दिक्कत ही नहीं है. Okay, so this is the case we should take. So what should happen? My 0.4% of duty cycle, okay, should be equal to 10 nanoseconds. Okay, so ideally if you I'll just take one more slide. So what should happen, tell me? 0.4 of my duty cycle, okay, should be equal to 10 nanoseconds. Ideally speaking, what should happen? 0.4 t should be, this time should be greater than or equal to 10 nanoseconds. ये है condition actually. Okay, so but nothing is specified, so I'm taking equal. Ideally 0.4 t क्या होना चाहिए, 10 से ज़्यादा होना चाहिए. So now if you calculate the t value कितना होगा बताइए? So this will become 10 by 0.4, 100 by 4, 25 nanoseconds. 25 nanoseconds means frequency of operation will be 40 megahertz, I think. Yeah. Okay. So 1000 by 25 is 40. Okay. So 40 megahertz. So wonderful question, please. Understood? So मैं ये model question पे ध्यान दीजिए. So these model questions can be asked on asynchronous circuits because he clearly mentioned in EC. So this is more important for EC, friends. Okay, but electrical nonetheless. Okay, friends, पूछ सकता है. We say electrical. We don't know. Questions can come all randomly. All questions come. So ये भी आ सकता है, ये भी आ सकता है. But this is a wonderful question. Not at all difficult. Okay, we have done some similar questions in the class also. So I wanted to cover this because this is very important from the gate perspective, please. Especially gate perspective. This is very important question. Okay, आपको समझ में आ गया होगा. 2 flip flops, 0 delay. If flip flop have a delay, क्या करेंगे? भाई delay add कर दो. Okay, if the flip flop has a delay, what should happen? This plus this. Okay, both of them should be there. Okay, this need not be added because ये off time में चला जाएगा. Okay, but this plus this should be taken into consideration, please. Understood? Consideration. ठीक है? Okay, good. Similar better questions from setup time, whole time will solve, please. Okay, so nothing to worry about it. आपको समझ में आ गया होगा. ये synchronous है क्योंकि same clock is given but different triggering. This is working on positive edge, negative edge. The duration between distance should be definitely 10 nanoseconds minimum. Okay, right. Okay, so that's the story about this particular question. Now let us see this simple question. Okay, this question can be expected for 1 mark or a 2 marker. Okay, this is basically on the digital to analog circuits. Right, question is based on digital to analog circuits. Let's take this green color. Okay, what is happening? A 3-bit gray counter is given. You might be knowing gray code. Class में I told you shortcut also how to remember gray code. K-map से shortcut बताया. So how to remember the gray code. So we are having a gray counter. That gray counter is given to a 4-bit DAC. This is a 3-bit gray counter connected to 4-bit DAC. 4-bit DAC में there are 4 inputs. He is making one input permanently 1. एक input को permanently 1 कर दिया. So now he is asking us, okay, initial state of the gray counter is 0. Initial state of the gray counter is 0. Initially 0. Okay, no problem. The DAC is defined by. He did not give resolution. He did not give dissolution. The DAC is defined by this equation. He is giving this equation for the DAC. Okay. Normally, for the DAC, what we expect? We expect either VR, या full scale, या resolution. We should expect, right? कुछ ना कुछ तो देना चाहिए. But he gave the equation for the DAC. Okay. Now the output of the DAC for after 5 clock cycles. He is asking the output of the DAC after 5 clock cycles. So कैसे करेंगे? एक बार देखिए, सोचिए. Simple question है. So now let's see how this can be approached. सबसे पहले let's understand the gray counter. बहुत simple है and ये आ सकता है because if you don't know the shortcut you will spend lot of time. Okay, so normally how to do the gray code? फटाफट 2 मिनट देखते हैं, then we will see. Suppose for example friends, you are having 101 10111. How do you, this is binary. Okay, ये binary है. How do you find the gray code, please? ग्रे कोड कैसे करते हैं भाई, 2 मिनट निपटाते हैं, उसके बाद आई टेल यू द शॉर्टकट ऑफ रिमेंबरिंग थिंग्स. फर्स्ट बिट एज इट इज, फर्स्ट बिट एज इट इज. ओके, ग्रे कोड करना है, आई वांट टू कन्वर्ट फ्रॉम बाइनरी टू ग्रे. फर्स्ट बिट एज इट इज. सेकंड बिट के लिए क्या करते हैं, व्हाट विल यू डू फॉर सेकंड बिट, XOR. किसका XOR करना चाहिए, इफ आई वांट द सेकंड बिट आई नीड टू डू द XOR. whose XOR I should do, second bit and the previous bit. I want second bit, do the XOR of second bit and the previous bit. 0 XOR 1 क्या है, 1. Okay, I want third bit. What will you do, XOR, whose XOR, third bit and the previous bit, XOR. Okay, XOR of the third bit and the previous bit, 0 XOR 1, 1. Next, now we want the fourth bit, take the fourth bit and the previous bit, XOR, so 0. So this is the gray code. Okay, all of us know how to do binary to gray code. Okay, and this gray code is very simple, all of us know it. But now he gave a gray counter. In this question he gave a gray counter. Okay, ideally speaking, what you should do, you should take binary sequence 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1, a 3-bit sequence you should take, convert each and every bit to gray code. Ideally what should happen, okay, ideally you should take the binary sequence, okay, convert each value to gray code. Okay, convert each value to gray code, please, understood, 0 1 0, this is binary, you should convert to gray code. Okay, from binary you should convert to gray code, then you will get the gray sequence. Okay, but you will end up wasting time. See, ideally how to get gray code sequence, you should take binary then convert into gray code. Okay, so my shortcut already I have told you in the class also, just how to find the gray code, simple, just draw the K map. You want 2-bit, okay, I will tell you how to do, just do the numbering, A B 0 1 0 1, this is 0 1 2 3. So if you just see the gray code sequence of 2-bit, I will tell you the 2-bit gray code sequence. Okay, 2-bit gray code sequence I will just tell you. Okay, 0 1 3 2, this is the gray code sequence. Okay, so the gray code sequence is 0 1 3 2, so this is nothing but the 2-bit gray code sequence. Sorry, this is a binary sequence, this is binary. Okay, gray code sequence क्या होगा बताइए, gray code का 0 1 3 2, आप चाहे तो चेक कर लीजिए, you can check it, no problem. Okay, similarly if I want a 3-bit gray code sequence, okay, please remember my friends, gray code counter you will waste time, question tough नहीं है, it's not tough, you will only waste, your time will get wasted in the exam, that's very important. Okay, time should not be wasted. Okay, 4 5 6 7. Now if you try the gray code sequence, this is the gray code sequence for a 3-bit. Okay, क्या क्या है भाई gray code sequence में क्या है, 0 1 3 2 6 7 5 4, this is the gray code sequence for a 3-bit. That's it, बहुत easy है. If you remember the K map, it's a gray code sequence. Suppose in the exam 4-bit is given, 4-bit is slightly tricky. Okay, so let's show the gray code sequence for the 4-bit. Okay, let's say this is A B C D. Okay, 0 0 0 1 1 1 1 0. Okay, 0 0 0 1 1 1 1 0. So let's find, this is 0 1 2 3 4 5 6 7 8 9 10 11. Okay, 12 13 14 15, this is a 4-bit, right? Now let's see the gray code sequence, it just goes like a snake, just remember the snake. Okay, ऐसा जाएगा. Okay, it just goes like a snake, please, understood, just goes like a snake, just remember the snake. So like this, the gray code sequence will be 0 1 2 3. Okay, तो ये ऐसे ऐसे जाएगा, this is a gray code sequence for the 4-bit. Okay, बहुत simple है. In examination you just draw one K map, within 30 seconds gray code sequence आपके पास रहेगा, don't waste time in the exam. ठीक है, ये हो गया 4-bit gray code sequence, 3-bit. Now we want the 3-bit gray code sequence. Okay, directly आ गया अपने पास. So now you are having the sequence. Now this gray code sequence is connected to 4-bit DAC. Okay, so now let's 4-bit DAC is connected, so now with one of the bit is 1, and he did not give DAC resolution. Okay, so now let's see how to solve this question. Let's expand this fellow, let's first expand this fellow. So what is given is VDAC is equal to, okay, what is given here, I'll expand it, I equal to 3, you put I equal to 3, what happens, tell me. So 2 power 1 d3 plus, okay, I equal to 2, you put, this is for I equal to 3. Okay, put I equal to 2, when you put I equal to 2 you are going to get 2 power 0 d2. Okay, plus I equal to 1, you put 2 power minus 1 d1. Okay, plus this is 2 power minus 2 d0. Okay, so this is for I equal to 2, I equal to 3, but this is not standard form. What's the standard form? 2 power 3 d3, 2 power 2 d2, 2 power 1 d1, 2 power 0 d0, that's the standard form. So this is a given DAC equation, so I will bring it into standard form, I will bring it into standard form. How will I bring it into standard form? I have to do like this, 2 power 3 d3, okay, 2 square d2 plus 2 power 1 d1 plus 2 power 0 d0. This is the standard form. Okay, मुझे ये दिया गया, this is given, this is what I want, bring it into standard form. Okay, actually the standard form goes like this, k into, this k is called resolution. Okay, now what I will do, I have to bring this into this form. So क्या होगा बताइए, I will multiply and divide by 2 square. Okay, so what happens if I multiply and divide by 2 square, if I multiply and divide by 2 square, okay, 2 square, what happens, tell me? So you are going to get in the standard format, okay, and you are going to get k value as 0.25. okay, so this is nothing but my resolution. Okay, so 0.25 is nothing but my resolution. That's it, aa gaya. Very simple, understood? So k is nothing but 0.25 is my resolution, over. Okay, that's it. So now in this given question, I taught about gray counter, I taught about the DAC equation is given, I expanded the DAC equation, I got the resolution also, sab kuch hai. Now what is he asking? He is asking the value of the DAC after 5 clock cycles. Initially 0. It's a gray counter, initially 0. Okay, initially 0. First clock pulse, where will it go? It goes to 1. Second clock pulse, it goes to 3. Third clock pulse 2. Okay, next 6, next 7. Okay, you can just check please. Yeah, already sequence bata diya. I already told you the sequence. Initially 0. First clock pulse, it goes to 1. Second clock pulse, third clock pulse, fourth clock pulse, fifth clock pulse. So in the fifth clock pulse, it is going to 7. Okay, so the values are basically 1 1 1. Okay, the values are basically 1 1 1 1. ठीक है, since the values are 1 1 1 1 और ये भी 1 है, ये भी 1 है. Okay, don't you think the decimal equivalent is 1 1 1 1 15? Okay, now substitute कर लीजिए अंडर्स, now substitute कर लीजिए VDAC के लिए, you just substitute it. So VDAC is equal to resolution कितना है, how much is the resolution? 0.25 into, okay, into what is this value please, decimal equivalent क्या है, 15 है. This is nothing but decimal equivalent only, no? This is decimal equivalent only. So this is decimal equivalent is 15. So the answer is basically 15 by 4. So 3.75 is the answer. Simply 3.75 is the answer. इस question में हमने क्या क्या सीखा? Once sometimes equations can be given. Okay, gray code can be given, understood? Gray code can be given, equations can be given. It's very simple, not at all difficult. Okay, so in this question we have learnt about the gray code sequence. So we have learnt about the 4-bit DAC. Equations de sakta hai, high probability. Don't simply assume that he'll give full scale, he will give resolution. Many times he may not give, he may give like this also, understood? Like this also, not at all difficult. Bring it into standard form, bring it into standard form. So gray code sequence bata diya, so the answer is this please. Okay, I'm sorry. Yeah, so ये है story. So please don't forget about gray code sequence, important है. Okay, gray code सीधा से यही ना, so maybe this same thing may not be asked, but some similar form can come in the exam. So please be careful, please, understood? Please be careful. Okay, so now similarly let's go for the, ये भी हो गया gray code sequence. Don't forget the gray code sequence. Okay, so that's the simple question on the gray code sequence, right? Okay, now comes the most interesting question on setup time, hold time. Okay, now go through this question please. So now what I have done is, okay, I have taken a simple circuit. Setup time, hold time is important. Okay, last year also question came. I have covered exhaustively in the Telegram groups also. मैंने iPad पे पढ़ा के वो भी solution भी दे दिया, I mean this explanation भी दिया setup time, hold time का. Let me briefly explain for 2-3 minutes what is setup time, what is hold time. Okay, उसके बाद ये question कैसे solve करना है देखते हैं. Very simple question, very easy. We can expect this for 1 marker. For easy get or maybe 2 marker if people normally 2 marks के लिए दिया फिर भी people नहीं कर सकते. Question is actually 1 mark level only, okay, but if you know the concept it's easy. If you don't know the concept then it's 10 marks also you cannot solve obviously. So now let's understand what is the setup time, hold time. Okay, so now yeah, let's understand what is setup time, hold time. Suppose let's take a D flip flop, D or T whatever. Okay, right. You are giving some inputs here. You are giving some inputs here. जो भी input देंगे process होना चाहिए. Whatever input you give, processing should take place. This is edge triggered. Edge triggered means what? The circuit works only on the edges. Okay? Circuit works only on the edges. केवल edge पे काम करता है. The circuit works all only on edges. That means before काम नहीं करेगा, after काम नहीं करेगा. The circuit basically works only on the edges. Exactly edge पे काम करता है. Neither the circuit works before, neither the circuit works after. Okay? So now comes the concept called setup time, hold time. Okay, when the clock is changing, suppose this is my clock. Okay, so this is my clock. When the clock is changing, my input should not change. My input should not change. What is the meaning of setup time is, suppose for example, suppose this is the clock change. My D input can change here, my D input can change here, but it should get stable here. Okay? So इस region में my input should not change, please understand, my input should not change in this region. Clear? After that again it can change, my input can change here, please understood. So that is the concept. So during the clock transition, okay, my inputs should be stable. Okay, so for some time before, so basically what is setup time? The time before the clock edge, for which input should be stable is called setup time. Okay, clock pulse से पहले ही input to stable होना चाहिए, clock pulse के बाद भी थोड़ा देर input stable होना चाहिए, and this input stable होना चाहिए, that's called the hold time. That means what should happen? See what is happening now, my circuit is working only for small time delta t. Circuit जो है edge पे काम करता है. Okay, so circuit is ideally working only for small duration delta t, please understood, केवल delta t के लिए circuit is working. So sometime before, sometime after you leave, we should leave it. Okay, we are showing it like this, but ideally what happens? Ideally always it will be like this only, no, edges are always like this, sharp edges कभी नहीं होते. So we are telling that sometime before the edge, sometime after the edge, you please, okay, what are we telling is sometime before the edge, sometime after the edge, just wait, so that circuit works properly. Okay, so this time is called the setup time, the time before the clock edge, okay, by which input should be stable is called setup time. Okay, the time after the clock edge for which input should be maintained stable is called hold time. एक simple example देता हूँ, I'll give a small example. Suppose you want to catch a bus, you want to go to your village, you want to catch a bus, 9 o'clock bus है, so 9 o'clock edge will come, bus door will open, bus door is open only for delta t time, open होगा shut हो जाएगा. Okay, what we are telling is you be ready in the bus stand by 8:45. Okay, that 15 minutes 15 minutes is setup time. So before the bus comes only you should be ready in the bus stop, otherwise you cannot catch the bus because the door will open and shut only for delta t duration. Okay, during that time if you are run, you will miss the bus, so you will get some improper values. So the time before the clock edge for which input should be stable is called setup time. The time after the clock pulse also we should maintain hold time. Okay, now let's come back to this question. Now let's see this question interestingly. Okay, 2 D flip-flops are given. Okay, so one flip-flop has a propagation delay of 2 nanoseconds, second flip-flop has a propagation delay of 4 nanoseconds. The setup time is tau here is asking the value of tau. He gave the maximum frequency of operation is 200 megahertz. Okay, how do you approach these model questions? हमेशा याद रखिए, many students do mistakes here. Okay, how am I going to approach this question? Very simple. Okay, how am I going to approach this question is, always assume everything is ready in the circuit. Apply the first clock pulse. Okay, whenever you apply clock pulse, what happens? Disturbance is created in the system. If I apply the clock pulse here, disturbance gets created in the system, so ये भी काम करेगा, everything will start working in the system. After some time they will become stable, then only we should apply second clock pulse. Okay, what we are trying to find? We are trying to find the time duration between both the clock cycles. That's the concept, right? Sorry, 1 second please. Yeah, we are trying to find the time duration between both the clock cycles. That is what is the time period. So how can you solve these model questions? हमेशा many students क्या करते हैं, initially ready नहीं है, कैसे करेंगे? No, first assume everything is ready. That's the easiest way of doing things. Assume everything is ready, apply clock pulse. Once you apply clock pulse, what happens? System disturbance is created, so everything will start working. After everything gets settled down, then only we apply second clock pulse. So the duration is nothing but the time period. काम खत्म, easily हो जाएगा. Let's start. Suppose आपने क्या किया? 0 nanoseconds you apply the first clock pulse. Okay? 0 nanoseconds I'm applying the first clock cycle. Okay? So when can I apply the second clock cycle is the question. First clock pulse I'm applying at 0. When can I apply the second clock cycle is the question. So 0 पे apply किया, जैसे 0 पे apply करता हूँ तो क्या होगा? It's a synchronous circuit. So this will also work. ये भी काम करेगा. Both are working at the same time. Okay. So this started at 0. This also started at 0. Okay. This will give output at 2 nanosecond. Okay. This is going to give output at 4 nanosecond. Okay. Clear? What is happening? The same output is going here. Understood? The same output is coming here, please. Understood? Same output is going to come here. Okay. The same output will come here, please. Understood? Same output is coming here at 4 nanoseconds, please. This fellow is only coming at 4 nanoseconds. Okay. Clear? The same fellow is coming at 4 nanoseconds. Simple. So if you just observe here, please. Understood? As soon as I give the input at 0 nanoseconds, what is happening? This output is coming. Same time, after 4 nanoseconds, this output is coming. Okay, so what is going to happen? The same output is getting applied here, understood? So 4 nanoseconds, this input is ready. Okay, 4 nanoseconds, this input is ready. Okay, but don't you think input is ready by 4, but I have to wait for some more time called setup time, okay, before applying the next clock pulse. For this flip-flop, the input is, see, I gave the first clock pulse. So what is happening? The input is getting ready here, understood? Input is getting ready, input is getting ready here, okay. So what is going to happen, please? Input is getting ready, input is getting ready. So by 4 nanoseconds, understood? 4 nanoseconds, this input is ready. But I have to wait for some time tau, okay, I have to wait for some time tau, such that what happens, that is called the setup time. Yani the variation plus the waiting time should be the total time for this particular flip-flop, understand? For this particular flip-flop, please, for this particular flip-flop, okay. Similarly, if you just see, please, understand, isko dekhiye, please, let's observe here, okay. 2 nanoseconds, this value is coming, okay, but don't you think this is coming at 4 nanoseconds, okay. आपने clock pulse दिया, 2 nanoseconds, this output is coming, but this is coming at 4. This is going to take 2 more, understand? This is going to take 2 more. So what is going to happen? This output with this here will come at 6 nanoseconds, please, understood? 6 nanoseconds. This fellow will come at 6 nanoseconds. So, so this value is coming at 6, so I have to wait for tau more, understand? I have to wait for tau more, okay. So what is going to happen here? So this is basically, we can apply the clock pulse as 4 nanoseconds plus tau. For this I can apply plus 6 nanoseconds plus tau, understood? 6 nanoseconds plus tau. So what I should take maximum? I should take the maximum time as 6 nanoseconds plus tau, okay. So here 6 nanoseconds plus tau, understood? 6 nanoseconds plus tau is the total time I should wait before applying this next clock pulse. ठीक है, एक और बार बताता हूँ, देखिए, बिल्कुल टफ नहीं, it's not all tough, okay. I apply first clock pulse, I create disturbance. When can I apply second clock pulse? Okay, as soon as I apply first clock pulse, 2 पे ये output आया, 4 पे ये output आया, okay, right, हो गया. The same output 4 is coming at this point. So 4 पे this input is ready by 4, but I can't apply at 4. I have to wait for a time of setup time. यानी simple setup time को add कर दीजिए. Just add the setup time there. Okay? इतना duration wait करना जरूरी है. You have to wait for the tau time. That means 4 plus tau is the time for which I can apply the clock pulse here. That means this is ready for every 4 nanoseconds plus tau. ये ready हो जाएगा. Tau is the setup time. इस पे आइए. Come here. This is coming at 2. ठीक है? Now when can I apply here is the question. But this 4 is also getting applied here. See, 4 is also getting applied. So this is coming at 4. So we have to take the maximum value 4. This is taking 2 more, 4 plus 2 6. So 6 nanoseconds is the time where this value is coming. But I have to wait for tau again. So 6 nanoseconds plus tau, okay, is nothing but my t. What is the frequency of operation? 20 megahertz. Convert कर लीजिए अभी. So 1 by 20 कितना होगा बताइए? 1 by 20 mega. So 1 by 20 mega. So 20 into 10, so we can say 10 power minus 6, okay. So 10 power minus 6, this is nothing but 0.5 into 10 power minus. So we can just simply say 50 nanoseconds, I think, yeah. So we can simply say 50 nanoseconds. Now substitute कर लीजिए, you will get the answer. But this is how you are supposed to approach the question. Question को ऐसा approach करना, okay, करना चाहिए, okay. It's not at all difficult, please, understood, not at all difficult. So if you just see here, this is 1 second, calculate कर देते हैं. So 1 by 2 is 0.5 into 10 power minus 7 into 10 power minus 7. So this is nothing but 50 into 10 power minus 9. 15, this is nothing but 50 nanoseconds, okay. So tau value पूछ रहा है, निकाल सकते हैं ना, क्या दिक्कत है? So tau, you can just simply calculate the tau value. Whatever is the tau value, will answer, you will get the answer. But concept is this, okay. So very very simple. हमेशा we should wait for a time tau. ये पहले ये calculate कर लीजिए. यहाँ तक तो everybody will do. ठीक है? ये 4 आ जाएगा, ये 6 आ जाएगा. Wait for some time tau. You will get the answer, please. Understood? You will get the answer. Okay. Next. Let's go to the next question. Okay. I'm hoping all of you have understood. Now quickly let's take a simple question on the ROM. Okay. This is also one good question. This is a 3 to 8 decoder. Okay. 3 to 8 decoder. Now this is a simple ROM circuit. Go through the question. Question can come like this on code converters. ठीक है, code converters. इसको कैसे approach कर सकते हैं? How can we solve this question? हमेशा याद रखिए, the only way is writing the truth table. Okay. Here for this circuit x2, x1, x0 are the inputs. y2, y3 these are the outputs. Let's write the truth table for this. Okay. कैसे लिखेंगे truth table? बहुत simple है, बिल्कुल tough नहीं है. It's not all difficult. Okay. So it's not all difficult, please. Let's see how can we write the truth table for this. Okay. So I will write it here. 1 second. Yeah, I will write the truth table here. You just observe here. Let's say this is my x2, x1, x0. maybe we'll write in the next page, that's better I guess. Okay, so let's write it here, x2, x1, x0. Okay, now this is y3, y2, y1, y0. So let's fill up all the possibilities, 0 0 0, 0 0 1, 0 1 0, 0 1 1, okay, 1 0 0, 1 0 1, okay, 1 1 0, 1 1 1. ठीक है, now let's see the y3 please. What are the minterms for y3 बताइए, y3 का क्या क्या minterms है, जहाँ पे contact, these are called contacts. Okay, in the ROM these are called contacts. जहाँ पे contact है वहाँ पे 1 मान लीजिए. Okay, wherever contacts are there, treat them as 1. Okay, so बताइए what are the contacts, tell me for y3, 6 and 7. 6 and 7 are the contacts. Okay, for y3 6 and 7 are the contacts. For y3 6 and 7 are the contacts. Just fill up everything, you fill up please, 6 7 and 1s. Okay, right, next let's go to the previous page. What are the contacts for y2 बताइए, y2 4 and 5. 4 and 5 are the contacts for y2. Okay, no contact means 0. Contact नहीं है means 0. Understood, simple, याद रखिए, contact नहीं है तो 0, contact है तो 1. Simple, over. ROM is so simple. Okay, so contact नहीं है तो basically 0. So sorry, what are the numbers please, भूल गया. So 4 and 5, understood, 4 and 5. Okay, so 4 and 5 please, 0 0, okay, 0 0 1 1, next 0 0, next, over. What are the contacts here, tell me, 2 and 3, 2 and 3. So now 2 and 3 please, this is okay, 2 2 3, 2 3, okay, next here 1 3 5 7 I think. Okay, yeah, हो गया. So now this is the table I got. Over. Now what is that he's asking please, he's asking what does it do, does it convert binary to XS3? First question, XS3 binary to XS3 not possible, understood. The reason being, you can just check, XS3 means 3 should get added. Okay, is 3 getting added, you see here 0 के लिए 0 आ रहा है. Okay, 0 के लिए 0 आ रहा है, no chance. 1 के लिए 1 आ रहा है. Okay, 2 के लिए 2 आ रहा है. Okay, 3 for 3 you are getting 3. Okay, for 4 you are getting 4, for 5 you are getting 5. Okay, but for 6 you are getting 8. Okay, and for 7 you are getting 9. Okay, you might have, by seeing the table you might have understood, but see, let's see. Okay, XS3 not chance. Okay, now is it binary to gray code, ye bhi no chance. Okay, because for gray code same number of bits should be there na. If 4 bits are there, 4 bits should be there for gray code, you will have, should have same number of bits. Gray code also no chance. Now let us see this interesting base6 converter. Okay, what is base6? When you say base6, okay, it's a simple question from number systems. This is basically base6. So if you see, let's do it for base6 please. Suppose for example, okay, when you say base6, what are the numbers in base6 बताइए. Okay, base6 में numbers कैसे लिखते हैं, how do you write the numbers in base6? I will write decimal here and I will write base6 here. Okay, 0 1 2 3 4 5 6 7. How will you write numbers in base6 बताइए. So इसको 0 लिखते हैं, 1 लिखते हैं, 2 लिखते हैं, 3 लिखते हैं, 4 लिखते हैं, 5 लिखते हैं, 6 को लिखते हैं 1 0. Okay, 6 is written as 1 0 in base6. इसको क्या लिखते हैं 1 1. Okay, इसको 1 1 लिखते हैं. अगर 8 लिखना है तो क्या लिखेंगे 1 2. That is how you write. Okay, कंटिन्यू करते हैं, लेट्स कंटिन्यू. 9 के लिए क्या लिखेंगे 10 11 12 13 तक लिखते हैं. चलो 9 के लिए क्या लिखेंगे बताइए 1 3, this is 1 4, this is 1 5. जैसे मैक्सिमम टच होता है. In base6 the digits are only from 0 to 5. Base6 digits are only 0 to 5 please, understood. 0 1 2 3 4 5. Okay, digits are only 0 to 5. So when maximum touches, next digit will be 2 0. जैसे 19 के बाद 20 आता है ना, वैसे ही मैक्सिमम टच होने के बाद 2 0 आ जाएगा. नेक्स्ट नंबर विल बी 2 1. So that's the basic point. So if you just observe here, this is called the base6. Base6 is basically 0 1 2 3 4 5. 0 के लिए 0, 1 के लिए 1, 2 के लिए 2, 3 के लिए 3, 4 के लिए 4, 5 के लिए 5. 6 is written as 1 0, 7 is written as 1 1. Okay, now हो गया. Come here. This is called as, okay, ये तो binary है. Okay, ये तो binary है. This is called binary coded base6. This is called binary coded base6. Base6. Okay, so binary coded base6. You might have heard of binary coded decimal. आपने binary coded decimal सुना है. This is binary coded base6. That means you're coding in binary. Simple. देखिए simple मैं यहाँ पे दिखाता हूँ. देखिए यही चीज़ मैं binary में coding करता हूँ. I'll do the same thing coding in binary. I will keep 0 0 0. Okay, 0 0 1, 0 1 0, 0 1 1, next 1 0 0, next 1 0 1. ये binary coding कर दिया. ये 1 0 को कैसे लिखना है? These two are different digits, just like how you do in BCD. जैसे BCD में करते हैं वैसे ही कर रहे हैं. ओके इसको क्या लिखेंगे 001 नेक्स्ट 000 ओके इसको कैसे लिखेंगे बताइए 001 नेक्स्ट 001 ओके दैट इज हाउ कोडिंग हैज टू बी डन हो गया दिस इज कॉल्ड बाइनरी कोडेड दिस इज कॉल्ड बाइनरी कोडिंग ऑफ बेसिक्स जैसे बाइनरी कोडिंग ऑफ डेसिमल होता है वैसे ये बाइनरी कोडिंग ऑफ बेसिक्स है तो आई हैव टेकन इंडिविजुअल डिजिट एंड कोडेड हर डिजिट का कोडिंग किया ठीक है व्हाट आई एम ट्राइंग टू डू नाउ आई विल रिमूव द अननेसेसरी जीरोस जो भी अननेसेसरी जीरो से हटा दूंगा इफ यू रिमूव द अननेसेसरी जीरोस इफ आई ऐड जीरो हियर आंसर तो नहीं बदलेगा ओके सो आई एम रिमूविंग अननेसेसरी जीरोस सेम टेबल यहाँ पे जो टेबल है ओके ये टेबल यहाँ पे है देखिए ठीक है दिस टेबल इज प्रेजेंट हियर अंडरस्टूड 0 के लिए 0 1 के लिए 1 2 के लिए 2 3 के लिए 3 4 के लिए 4 5 के लिए 5 6 के लिए 1 0 which is 8 7 के लिए ओके 9 ओके सो हियर हाउ मच इज गेटिंग एडेड बताइए 6 को 2 ऐड हो रहा है 7 को 2 ऐड हो रहा है सो वी आल्सो रिमेंबर करेक्शन फैक्टर आपने 808 पे पढ़ा होगा सम ऑफ यू माइट हैव रेड 8085 उसमें डा इंस्ट्रक्शन होता है डा डेसिमल एडजस्ट एक्यूमुलेटर आपने 808 पे पढ़ा होगा सो डेसिमल एडजस्ट एक्यूमुलेटर में करेक्शन फैक्टर ऐड होता है 6 ओके प्लस 6 ऐड करते हैं वहां पे डा में यहाँ पे 2 ऐड होता है बिकॉज इट्स बेसिक्स कन्वर्टर ठीक है वो डेसिमल है 6 ऐड होता है ये बेसिक्स है तो 2 ऐड होगा ओके सो वी से द करेक्शन फैक्टर इज आल्सो इक्वल टू 2 अंडरस्टूड करेक्शन फैक्टर इज 2 ओके सो द आंसर इज बेसिकली बाइनरी टू बेसिक्स कन्वर्शन अंडरस्टूड बाइनरी टू बेसिक्स कन्वर्शन सो दैट्स वेरी वेरी सिंपल प्लीज अंडरस्टूड वेरी सिंपल थिंग प्लीज ठीक है आई एम होपिंग आपको समझ में आ गया होगा ठीक है सो माय फ्रेंड्स इट्स वेरी सिंपल सो आई हैव ट्राइड कवरिंग एग्जॉस्टिवली एज मच एज पॉसिबल अंडरस्टूड सेटअप टाइम होल्ड टाइम सबसे ज्यादा इंपॉर्टेंट है इफ यू आर ईसी के लिए क्या क्या इंपॉर्टेंट है बस क्विकली बता देता हूं मल्टीप्लेक्सर्स इंपॉर्टेंट ओके इलेक्ट्रिकल फ्रेंड्स फ्लिप फ्लॉप कन्वर्शंस इंपॉर्टेंट दिस टाइम ठीक है सो फ्लिप फ्लॉप कन्वर्शंस ऑलरेडी क्वेश्चंस हैव कम एंड इट्स आल्सो वेरी इंपॉर्टेंट सो मल्टीप्लेक्सर्स फ्लिप फ्लॉप कन्वर्शंस एक बार रिकैप कर लेते हैं फटाफट जस्ट रिकैप करते हैं बिफोर वी गो अहेड ठीक है सो right 1 second please yeah first question so flip flop conversions पे दिया multiplexer plus flip flop conversion individually also both are important both for EC and electrical ठीक है ये कवर कर दिया ये आपको समझ में आ गया होगा कैसे हमने कवर किया है ठीक है so now this is very interesting questions of this model can be expected for 2 markers okay 2 markers के लिए important है where he is trying to give some extra combinational logic plus a register रजिस्टर को कॉम्बिनेशन लॉजिक देके पूछेगा कि ये कैसे काम करता है कितने क्लॉक पल्सेस के बाद वापस आएगा क्वेश्चंस आर देयर बट दिस मॉडल इज नॉट देयर एक्सपेक्टेड है ये एक्सपेक्ट कर सकते हैं बिकॉज स्टूडेंट्स मेंटालिटी इफ यू सी डर जाते हैं दे गेट स्कैर्ड बाय सीइंग दीस मॉडल क्वेश्चंस बट दे आर नॉट टफ थोड़ा सोचेंगे तो आंसर आ जाएगा लाइक दिस ओके राइट ठीक है नेक्स्ट ओके नेक्स्ट दिस इज ऑल्सो ट्रांसमिशन गेट्स ये 1 मार्कर के लिए इंपॉर्टेंट है भाई इफ यू आर ईसी डेफिनेटली इंपॉर्टेंट प्लीज ओके इलेक्ट्रिकल मुझे नहीं लगता द ट्रांसमिशन गेट्स पीछे से सब पूछेगा फिर भी पूछा यू नो देम यू कैन आंसर देम वेल ओके बट स्टिल इसी के लिए इट्स मोर इंपॉर्टेंट ओके सो डोंट गेट स्कैर्ड और कंफ्यूज कि ऐसे कुछ भी दे दिया रीड्रॉ देम 90% प्रॉब्लम्स विल बी सॉल्व्ड इजीली ओके नेक्स्ट ठीक है तो ये वर्किंग ये हो गई दिस इज अगेन इंपॉर्टेंट फॉर ईसी ओके इलेक्ट्रिकल मुझे नहीं लगता पूछेगा बट एनीवेज नथिंग रॉन्ग इन नोइंग इट तो प्लीज okay this type of delay critical questions सिलेबस में भी दिया है critical timing okay EC सिलेबस में दिया है critical timing analysis मतलब यही होता है okay critical timing analysis so how do you so all these things okay so critical timing analysis was given in EC gate syllabus okay तो यही ऐसे मॉडल क्वेश्चंस आते हैं critical timing में याद रखिए थोड़ा ध्यान से okay easily solve कर सकते हैं don't complicate the things right next okay so next 1 second next ये भी DAC circuits also important my friends okay I just gave a simple DAC all of us know how working of DAC successive approximation dual slope we have done exhaustively in the class please go through the notes आपको पूरा समझ में आ जाएगा it's pretty simple so here I've just given gray code gray counter दिया उसके साथ ये भी DAC को interface किया and I also told you the shortcut for this particular gray counter please ठीक है okay next ठीक है ये सबसे ज्यादा इंपॉर्टेंट है फॉर 2 मार्कर ओके एंड दैट्स अ सिंपल स्टोरी सो हियर सेटअप टाइम इज आस्क्ड ऑलवेज रिमेंबर ये टाइमिंग कोई भी निकाल सकता है ये 4 पे आउटपुट आ रहा है तो 4 यहाँ पे आ जाएगा ये 6 पे आएगा ये तो निकाल सकते हैं ओके याद रखिए व्हेन सेटअप टाइम इज गिवन पक्का ऐड द सेटअप टाइम टू दैट वैल्यू ठीक है दैट मींस ये 4 पे आउटपुट यहाँ का आउटपुट यहाँ पे आया 4 पे बट आपको टाउ वेट करना पड़ेगा टू गिव द नेक्स्ट क्लॉक पल्स ठीक है वही सेटअप टाइम है सेटअप टाइम इज एक्चुअली वेटिंग टाइम तो tau ऐड कीजिए, यहाँ पे भी tau ऐड कीजिए, वॉट एवर इज द नंबर यू कैन जस्ट टेक केयर ऑफ द नंबर्स, नंबर में इक्वेशन में क्या है, बट बेसिकली 6 प्लस tau शुड बी इक्वल, दिस शुड बी इक्वल टू t, आप इक्वेट कर लीजिए, ठीक है, राइट। The last question based on the ROM please. ROM question. Suppose some question comes like this. ROM या PLA भी दे सकता है. Same story. PLA दिया भी फिर भी same story. Just find the min terms. Okay. And you see the logic please. Understood? See the logic. ये model question भी आ सकता है. Okay. Friends, all the best for your GATE exam. God bless you. Thank you very much. Okay.